Hiya! On today's episode of Bridging to a 7, we'll have a look at a complex simultaneous equation question. Now, this question rarely shows up on IB for a simple reason that is quite complicated. And we're doing this not because we hope that it will show up, but rather, I would like to focus on the reasoning behind various decisions that we have to make while solving the question. So, without any further ado, let's get started. We can see two equations here. One in terms of z and w, one in terms of w star and z. And we want to find the complex numbers z and w. The idea behind this, there are two common strategies that you would use in these kind of questions. And the common strategies are either brute forcing through all of this, obtaining four equations in four unknowns, or you isolate one variable. Exactly the same way you would do when solving a typical set of simultaneous equations. In this case, I would choose the second option, simply because if you go through all the manipulations, the odds of you making an error is very, very high. So, if we are to isolate one variable, what variable should we use? What complex number should we isolate? We can isolate w or we can isolate z. Clearly, z is a better choice because z appears in both equations. So, if we keep the first equation as is, and we multiply both sides of the second equation by 2i, we can now starting to eliminate variables. In fact, we can eliminate 2iz altogether. So, to do that, I am going to subtract the first equation, the second equation from the first equation. Subtracting the second equation from the first equation, we would get w minus 6 is equal to 5 plus 7i minus 8i plus 2 w star. And from this point, I think we all know what to do. Let w equals a plus bi, equate the real part, equate the imaginary part, and we shall obtain two equations in a and b. So, left hand side, right hand side. You may want to slow down a little bit. Group all the real parts together. Group all the imaginary part together. Equating the real parts. Equating the imaginary part. And then we found out that A is equal to 1. Slow down. Take your time with algebra, because the moment you screw up the calculation, it is much easier to just restart from scratch and abandon all you've done, instead of wasting hours looking for one tiny slip that you've made in the middle of a sea of algebra that we have done so far. If A is equal to 1, B is therefore equal to 1 as well. So W is therefore 1 plus I. We can now plug W back into our equation. Second equation, 4 minus I times W star is equal to Z minus 3I. W star is 1 minus I. So therefore Z is equal to 4 minus I, 1 minus I, plus 3I, which is 3 minus 2I. Therefore, Z is equal to 3 minus 2I, and W is equal to 1 plus I. And this is the end of the question. It is not hard, but you need to have a strategy to isolate W or Z, and from there, do a lot of algebra to arrive at the final correct answer.